The next type of graph we're going to talk about, besides dot plots and histograms, are something called a box-and-whisker plot. It has a very strange name, but it's actually a very cool way to display data. So I'm going to explain this to you with an example. I think it's the easiest way. I'm not going to give you a definition. So here we've got this data like we've had before. 16 students receive scores on a math quiz. So here are the scores. They start at 52 and they go all the way up to 98. So the first thing you have to do when you're doing a box and whisker plot is the letter A here and finding the median. Now it's been a long time since you guys have had stats, but the median means the middle value. Okay, so when I look at this set of data, in order to find the middle value, my data has to be in order from least to greatest. Now this is really fortunate because when I look at this set of data right here, I see that it's already from least to greatest, which is really nice. So if I want to find my middle value, I have to count from either end. So I've got 98, 52, 92, 60, 91, 66, 84, 66, 82, 68, 80, 72, 75, 72. So those are both equal on either side. So I notice here that 73 and 74 are both my middle values. Now, since I've got two numbers that are in the middle, what I have to do is I have to figure out what's in between 73 and 74. So here's 73 and 74, my two middle values. I know that between 73 and 74 is 73.5. Halfway between is always a 0.5, right in the middle there. Okay. Now if you're not sure about that and you'd like to use your calculator to double check, you can always go into your calculator, add 73 plus 74 together, hit enter, and then divide by 2. Find the average between them. And you'll see the calculator will tell you 73.5. Okay, so that's the first step, is to find that median value. And when you do find that value, I would just put an M with it to label that as the median. So the median of this data set is 73.5. Something else you might want to check when you're doing the median to really make sure you've done it correctly is to count the values on either side. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. If you've got the same values on either side, then you've found the median value. It's just kind of a way to check to make sure, because you are dealing with a lot of numbers. Okay. The next thing that is nice to do on a box and whisker plot is to find something called the range. Now we've talked about this value before. The range is the difference between the largest data value and the smallest data value. So my largest value is 98. And my smallest value is 52. Okay, so my range will be 98 minus 52. So I'm going to go to my calculator, 98 minus 52, and I get a range of 46. So that's my range. Then after you find the range, we're going to label this 52 and 98 something. We're going to label the 98 your maximum, and we're going to label the 52 the minimum. Okay, labeling is going to be critical in this learning target, just a heads up, to label all these values, because you need all these values to draw your graph. Okay, now we're going to talk about two really interesting values. We're going to talk about something called the first quartile, and we're going to start talking about something called let's make this a different color, the first quartile, and we're going to talk about the third quartile. Now I know those are words you've probably never heard before, okay? But the first quartile is representing the lower half of the data. Now what I mean by lower half is I mean all these values split by the median. So see how the median is right here? Well, we've got now a new little set of data called the lower half of the data that I've underlined here in blue. The upper half of the data then is just the other side. It's the 74 up to the 98. That's the upper half of the data. So the median splits the data into two separate little mini sets of data. Okay? And the first quartile is actually the median of this little data set. So the first quartile is a median. So when I look at the blue, I'm going to try and find the median. So 73.52, 72.60, 72.66. Here, the two values right in the middle are this 66 and 68. Now halfway between 66 and 68, you can use your calculator. You can do 66 plus 68 divided, hit enter first, and then divided by 2 gives me 67, which makes sense. 67 is directly between 66 and 68. So 67 is what we call our first quartile, and we're going to label that Q1. So 67 is my first quartile, okay? Now we're going to do the same thing, but we're going to do it with the purple set of numbers. So I work my way out, and then I work my way in to find those middle numbers, and in this case it's 82 and 84 are my median for my upper half. Now halfway between 82 and 84 is 83. 83 is right in the middle, and that's the number we want to have. So that means that my third quartile is 83. So Q3 equals 83. Okay, now see how I've labeled my data set up here? I can't express to you enough how this needs to happen. This labeling, I've circled my min-max, I've labeled my median, and I've labeled my lower quartile and upper quartile. Okay, this is really critical because you need all of these values now to make your plot. Okay, so that's what this next part is right here. Okay, so the first and third quartiles are known as the lower and upper quartiles. I've just mentioned that. The quartiles, the median, the lowest and highest values in the data set comprise what's known as the 5-number summary, right? We've got 5 numbers. We've got the green as the median, the blue is the Q1, the quartile 1, the purple is the third quartile, and then 4 and 5 is my min and max. Those are the 5 values we need, the 5-value summary. So this plot, and how we're going to plot this on the number line, looks kind of weird. So I've got to label these numbers here, and for the most part in this learning target, I'm not going to make you do this. I'm not going to make you label your own number line because it does get a little bit tricky. So I'm just going to go ahead and label this for us. So I'm going to make this, let's do it in black here. I should have done this before, but I'm going to label this 50, then 60, 70, 80, 90, and 100. Now I labeled it this way because I know all of my values, if I scroll back up, are between 50 and 100. So that's why I picked those values, just so it kind of made sense. So I'm going to go ahead and write down my 5 numbers that I need. So my median was 73.5. My first quartile, my Q1, was 67. My third quartile that we just talked about was 83. And my minimum was 52. And my maximum was 98. So there's my 5-number summary. Now here's what I'm going to do. I'm going to take each of these numbers, I'm going to plot them on this bar line, on this number line. Okay? And you're not going to make dots. You're not going to do this. You're not going to make bars. You're not going to do this. Neither of those 2 things are going to happen here. What you're going to do is you're going to make lines. So I'm going to go look for my min and max. 52 is about right here. I'm going to label that 52. And then I'm going to draw a line above it like that. Okay? Then I'm going to plot my maximum. 98 is about right here, and I'm going to label that 98. You should too if there are numbers that aren't directly on the number line. Label them so I know what you're estimating. Now I'm going to plot the other 3. The Q1 was 67, which is about right here. I'm going to draw a line for that. My median is 73.5, which is about right here. And you can estimate. It's okay. I don't need you to be 100% precise, but I need you to be close. And then 83 is about right here. So I've plotted all my points with lines on the number line. Now why is this thing called a box and whisker plot? Because your quartiles and your median are going to form a box. You make a rectangle. Then you connect that box to the minimum and maximum, and so it kind of looks like a box and 2 whiskers. That's why this is called a box and whisker plot. which I think is kind of cool because cats have whiskers and this has whiskers. So that's why I kind of like these, okay? So a couple things to remember is I need you to label your 5 values. So this is min, max, median, Q3, and Q1, okay? I'd like you to label those just so I know that you're realizing where those lines go, okay? Let's do one more before I want you to try one on your own. So I'm going to do one more, and this one is a little bit different because when you look at this data here, the number of runs scored by a softball team in 20 games, notice none of these values are in order. You cannot make a box and whisker plot unless you have actually found them in the right order. Now this is tricky because you can't miss a number. So here's what I do. I find the lowest value first. So I'm looking at this list of numbers and I'm noticing that there is a number 2. 2 is my lowest value. So I'm going to cross it off and I'm going to write 2 here. Now I'm going to see how many 3s I have. I have 1, 2, 3 3s. So I'm going to do 1, 2, 3 3s. Now I'm going to find my 4s. I have 1, 2, 3, 3 4s. 1, 2, 3. Now I'm going to count how many 5s I have. I have 1 5 here, and that's the only one. I don't have any 6s, so I'm going to go to 7s. 1, 2 7s. And now I'm going to check my 8s. I've got 1 8 here and another 8 here, so that's 2 8s. I've got 1 9, 2 9s. And then I've got 2 10s. I've got an 11, and I've got 2 12s. Oh, and I've got a 14. Do you see how crossing them all off really helped? Because then I noticed I had this 14 left over. Crossing them off really helps you make sure you don't miss one. Then what I like to do before I do anything else is count these to make sure I've got 20. They tell me there's 20, so I should have written 20 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm going to go ahead and recount because I'm scared that I have made some sort of mistake. So let's go ahead and recount because maybe I just counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I just counted wrong. So notice that I had to check twice to make sure that I'd done it correctly. Okay, this is the number one place I believe students make a mistake. The other place students make a mistake is this next step right here, and that's finding that median value. Now, one easy way to find that median value is to take the number of data points you have. So in this example, I've got 20. I'm going to divide 20 by 2 because 2, when you divide something by 2, you're splitting it in half, which is what the median is. So I'm going to go ahead and count 10 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10th number. So that means that 7 and 8 are my median. So to actually get between 7 and 8, that's 7.5. So my median is 7.5. Okay, that's another easier way to calculate your median than just doing your back and forth like I did in the first example. Okay, so now I know that my median is 7.5, so I'm going to go over here and label median as 7.5. Now you've got to find the median of the lower and the upper. So my upper starts at 8 and goes to 14, and my lower starts at 2 and goes all the way to 7. Now I'm going to go ahead and find my median of those. I've got 1, 2, 3, 4, 1, 2, 3, 4. So my median of that lower data set are these two values, 4 and 4. Nicely that they're the same number. So then I know that Q1 is 4. So I'm going to go ahead and label that 4. Same thing on my upper set of data. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I've got 10 and 10 in the middle here as quartile 3. So I'm going to put 10 at quartile 3. And now the last two data points I need are my minimum and maximum. My minimum here is 2, and my maximum is 14. Okay. I'd also like you to be able to find the range of these of this data, and that's pretty simple. All you have to do is take the maximum minus the minimum to get 12. Okay, 12 is your range, max minus min. And now the easy part is you're just going to plot these on the box plot. So 7.5, so this is going by 2s. So 7 is about right here, so that means that this is about 7.5. I'm going to draw my line where 7.5 is. Now I'm going to go ahead and plot my quartiles. 4 is my lower quartile, and 10 is my upper quartile. And then I'm going to plot my minimum and my maximum. So minimum goes here, maximum goes here. Now just connect to make your box and connect to make your whiskers. Okay? Label this medium, median. I keep saying medium, I don't know why. Q1, Q3, minimum, and maximum. And again, because I had to estimate this little decimal guy, I wrote it in here. Okay, so when you're estimating decimals, write them in. Okay, so I'm going to go ahead and have you try one on your own. This is a data set again about math scores. You'll notice one really nice thing is that these points are already in order. So I want you to go ahead and find your 5 plot points, your medium. Oh my gosh, what am I doing? I keep saying medium. Your median, your first and third quartiles, and your min-max, and then I want you to create your whisker plot. Okay, remember to label your number line with numbers that are estimates. Okay, all right, good luck. So here are the values you should have gotten. Something really interesting about this data set is that unlike the others, you actually only had one value in the middle as your median, okay, which worked out really nicely because you didn't have to divide by 2. However, you should have noticed that you needed to divide by 2 for this 90 and 92, and you also needed to divide this in half with the 74 and 78 to get those medians, okay? So that is the basics of creating a box and whisker plot. So I want to talk a little bit about reading them and what information we can get from a box and whisker plot. So 20 of Mr. Ume's physics students recently took a quiz. The results of this quiz are shown in this box and whisker diagram. Assume that all scores are whole numbers. So we're given this diagram. We're not given any specific data points. So let's take a look at these questions. What's the median score on the math quiz? So we know what that means. That means we're going to go to this line right here because this is our median. Now this graph is going up by 2s, right? This is 52, 54, 56, etc. Okay, so because it's going up by 2s, I know the median is going to fall here at 71 because that's halfway between 70 and 72. So the median score here was a 71. The next question now says, what was the range? Now remember, range is your max minus your minimum. So my maximum right here is 84, because 82, 84. And my minimum, if this is 50, this is 52, and this is 54, then this guy is 53. So that means if I want to do my range, I have to take 84 minus 53, and when I do that, I get 31 as my range. Okay? So now the next question is kind of interesting. It says, what score was greater than or equal to 75% of all scores on the quiz? And you're probably thinking, what the heck, Miss Pennington? We have never talked about percents in this data. So something really interesting about box and whisker plots. Okay, and I'm going to erase this up here so you can see. Every little piece from the whisker to the box, from Q1 to the median, from the median to Q3, and then from Q3 to maximum represents 25% of the data. Now remember, 25% is like a fourth, right? Like 4 quarters make $1. So if you think about this like $1, like every box and whisker plot represents $1, then each of these pieces is a quarter of that $1. So when I look at this question, what score was greater than or equal to 75%? Well, we want greater than or equal to. So if I take this guy, this 25%, I take this 25% and this 25%, well, isn't 25 plus 25, isn't 3 quarters equal to 75%? So we want all of the scores that are greater than that, meaning we want this chunk right here, because all of these other pieces are going to be less than. Okay, this guy is where we're going to be greater than. Okay, so that is what we're looking for when it says what score was greater than. If this says what score was less than 75%, we'd want to be looking at this piece right here. Okay, so now with that little percentage information, now we actually have to answer this question of what score was greater. So that is right there, this score right here. Okay, because that's the cutoff for 75%. After that, the percentage increases, correct? So now I'm going to go 72, 74, and 76 is where that line is greater than 75%. That question is probably about the hardest question that we're going to see in this learning target concerning percentages with box and whisker plots. Okay, so please keep in mind that those pieces are 25% of the data, which is really important going forward if you ever take stats again. Okay. The last question says, Mr. May regularly sets the passing grade on his quizzes to be the score of the lower quartile. So what's the passing grade on this quiz? Well, the lower quartile is going to be this guy right here, and that score is a 64. So for his class, a 64 is passing. Anything less than a 64 is failing. Okay? So that's one. This is a little bit of the kind of questions you're going to see about like my expectations for reading a box and whisker plot. Two other questions that I'm going to ask you to know is kind of being able to compare some box and whisker plots. So you'll notice that these box and whisker plots are set to different number lines. And the question is asking which of the following box plot shows a data set with the greatest median. So that means what you have to do is you have to go through each box and whisker plot and find the median. But the tricky part is that these number lines are going up by different intervals. For example, this guy goes from 20 to 40, so this has to be 30, right? And then that one has to be 25, so this is going up by 5s. This is 50. That means my median for this box and whisker is 35. Number 2, this is going up by, I think, 10s, 50, 60, 70, 80, 90. Now, I'm doing this very quickly. I'm seeing these intervals very quickly. You might not see them as quickly as I am, and that's okay. You might have to test a few values to figure this out, okay? So this is going up by 10s. That means this is 40, so my median for this problem is 40, okay? Number 3, I can tell that this is going up by 2s, 10, 12, 14, 16, 18, 20. My median is here at 22. And then finally, number 4, it's going up by 1s, 5, 6, 7, 8, 9. So that means that this is a median of 7. Now, of all these 4 numbers, which one is the biggest? Number 1. Okay, has the big, oh, no, not number 1, sorry. Number 2 has the biggest one at 40. My apologies. Okay. The last thing I want to talk about is another value we need to be able to find, and it's pretty simple. It's something called an interquartile range that we abbreviate to IQR. Okay? Now, an interquartile range sounds terrifying, but remember, we talked about a range as being like a maximum minus a minimum. So the interquartile range is just the quartiles, that range of the quartiles. So it's just taking this Q3 and subtracting it from Q1. Okay, so I'll show you an example here. This Q3 is at 20, so Q3 is 20. And Q1 is in between 10 and 11, so between 10 and 12, so Q1 is 11. IQR is just going to be 20 minus 11 to give you 19. Okay, so you're just finding the range of the quartiles, really, instead of the range of the whole thing. For this one, I've got a Q1, and I'm estimating here because this box and whisker is a little hard to read, but I'm going to say that this is, oh, sorry, I don't want that value. I want this value. This value right here, I'm going to say is 21. I know it doesn't really look like it, but it's a bad scale. And I'm going to say this guy is 25, okay? So now my IQR is just 25 minus 21 to give me 4. Okay. Now I know a lot of these values are tough to understand, like what do they mean, what do I do with them, and that's something that you're gonna figure out, or you're gonna learn later on in math if you take a statistics class. Right now, I really want you guys to be able to use this language, be able to create these plots and answer some simple questions about them. Okay. So please be careful in your practice with calculating median. Make sure that your lines are clear and that you've labeled your estimations. Okay? Good luck on your practice.